Good morning, everyone. Welcome. Nice to see so many of you interested in data science. I am very pleased to have an opportunity to share with you not only what is new in Microsoft technologies, but also what has been there for quite a while. You see, I don't work for Microsoft. I like to point out that although I have never worked for Microsoft, I have worked with Microsoft and their technologies for 27 years now. And in the last 13 of those 27 years, I have specialized as what is today called a data scientist. But of course, that's a new title. I used to be called predictive analyst, advanced analyst. I used to be called a data miner and a few other names along the way. But I'm sticking with the data scientist for a little while. Although it looks like we are already rebranding ourselves into AI engineers. So, maybe next year I will be an AI engineer. Anyway, let me do quick introductions. My name is Rafal Lukawiecki. I would be honored if you would like to stay in touch with me. I'll give you a few pointers how to do that very shortly. And at the end, my email address as well as Twitter handle rafal.net is at your disposal. If you snap any photos and you tweet them, I will definitely retweet them too. So thank you in advance for your implied consent. All right, this session is all about the DBA. I have worked with some of the world's best DBAs in my life. I have worked with a company which unfortunately doesn't want to be named, which is a great pity because they have 2,500 multi-core SQL servers running constantly and buzzing and doing all sorts of fun stuff. And I've worked with tiny organizations. But one thing is clear to me, that in my job as a data scientist, there is no way I could do it without a great DBA who's a little bit more than a DBA. It's also a little bit of a person inquisitive about data science and thinks along the lines of the way I think. And that's what I want to share with you because maybe you will enjoy jumping onto this career path. In terms of the nitty-gritty of this session, we'll touch on data science versus machine learning versus data mining versus artificial intelligence versus advanced analytics. It's pretty much all the same thing, but different angles of it. Technologically speaking, you'll see a good few different tools, and you will see both SQL Server 2016, a little bit of the upcoming technologies, R Server and Azure, and a bit of this and that. But really, I don't want to give you any in-depths on any of that. I want to give you pointers where to learn more. And one of the best places to learn more is to learn with me. If you would love to spend 5 days with me learning this in depth, I would welcome you on my 5-day in-depth course on practical data science. The stress is on the word practical in Dublin, London, Oslo, Prague, Stockholm. The Prague course, that's the correct date. We're actually doing 2 Prague courses because for some reason the first one sold out. And I'm coming to Chicago once again sometime in the spring. We haven't chosen the date, could be April or May. It's a fabulous location, not too far from the airport. If you want to stay in touch with me and you sign up to the newsletter, projectbotticelli.com/connect, I promise not to spam you more often than about 8-9 times a year, and you can always unsubscribe. I'll remind you about all of this at the end of the session. Why do my customers need me? I had to justify myself for the last 12 years, so I like to start almost all of my presentations with that because that will give you an idea what's there in it for people like me. In other words, why do we get paid? Well, I actually wrote an essay about it, about 4,000 words, which you can find free of charge on the website. The link is there in case you've downloaded the slides. Well, for the last 12 years, my customers want me to discover why they fail and why they succeed. This is by far the overriding reason for doing data science. Number 2, they want to understand themselves, their own customers and their products. Why? For example, to plan future more accurately. Some of my customers are ready to experiment before they make big decisions. And this is a very cool area that was almost unheard of in business a decade ago and now is extremely popular. It's called data-driven decision-making, or DDD, as if the term DDD didn't have like 100 other meanings. Data-driven decision-making is about having a crazy idea that you can quickly test on some small subset of data, and then you analyze the results under the microscope of data science to get a good feeling whether you should be going ahead or not with that idea. And we have a process for it, and it works phenomenally well. And it's well now discussed and adopted by some of the biggest companies in the world, you know, the Netflixes and Googles and Microsofts, and it's becoming more and more prominent for the medium and eventually smaller ones. However, some of my customers, very few still today, but increasing number of them, want to build systems that make autonomous decisions, effectively intelligent decisions, and that's the first step towards artificial intelligence. I have a lot of concerns about that, and I presented a session yesterday morning about some risks about AI that unfortunately are going to cause us losses. I know you can't re-attend it yesterday, but if you are interested in it, have a look at my slides. The session was called Artificial Intelligence, Is the Future Just About Machine Learning? I know the recordings of every presentation will be available for all of you to watch. Have a look for another take on why, in my opinion, a lot of businesses will not be building artificial intelligence, but something more akin to artificial stupidity before they learn how to do artificial intelligence. Okay. So what are we talking about? Advanced analytics, data science, or AI? Well, first things first, a lot of people talk about advanced analytics. It kind of sits at the old intersection of data acquisition, preparation, exploration, and visualization with the new dollop of data science. So that data science part added to traditional exploration is what makes it advanced analytics, more or less. Well, data science is not just engineering, but it also sits at the intersection of technologies. Notably, it's at the intersection of statistics, data mining or machine learning, an awful lot of data wrangling, and a tiny, tiny, tiny bit of this horribly named technology of big data, which I have always struggled to like the name, because of course there is no big data, there are only big and interesting complex questions, and anybody who talked about big data for the last 5 years, well, all of that data became tiny data today, and you can process it, you know, on your iPhone, so it's a moving target in many ways. However, data science is not just about that. Data science at its heart uses machine learning to find generalized patterns in your data. That means it looks for things which we can somehow reason from, apply to the future and to the unknown. You can use those patterns to explore the data and understand it better, but most people are interested in predicting. I always like to point out that the explorative use of machine learning is still more important than the predictive. 60% of my projects are explorative, 40% are predictive. I know the balance is changing towards predictive, but that's not always for the right reason. Very often, you should not be doing a predictive project until you've done, and well done, the explorative one. So learn about the pattern before you apply it. And also, predicting doesn't mean predicting the future only. This is called forecasting. This is, of course, what excites people a lot, but predicting the present and predicting the past is as useful. Knowing what happened in the past, as well as knowing what is happening now. You know, if you are running sales reports, as all of you probably do in one form or another, you learn what your sales were today, well, after the report ran, which for some of you will mean tomorrow, for some of you it means next Monday, for some of you it may mean next year. You don't have to do it like that anymore. You can create a predictive report which tells you what your sales are now, before you know what the sales were. With a dose of uncertainty, you can predict the present. This is called nowcasting, and it's a kind of a buzzword in finance right now, not always for the good reason. So you have forecast, you have nowcast, and you have hindcast. That's new terminology that was invented about 2 years ago, although we've been doing this for about 20 years at least. All right. I already said several times that data science is not technology. So what is it? It's the application of the scientific method of reasoning. What is the scientific method of reasoning? Other than it's one of those discoveries you have to make when you play Civilization 2, 3, 4, 5, and 6. Scientific method of reasoning is a process of having the craziest idea you want, tested by experimentation and a logical process of deduction that never tells you yes, you were right, or no, you are wrong, but it always tells you with a certain dose of uncertainty that perhaps your idea is indeed worthy of proceeding with, or maybe you should try again. This is an old principle. All of medicine that we have today relies on it. In fact, all of physics, not just quantum mechanics, but the traditional one, going probably as far back as Isaac Newton, although it was really in the last 200 years that the scientific method of reasoning was formalized. And that's why it's called the science. And it's not difficult to learn. You learn how to create hypotheses by writing two statements. Experiment is just trying things out. Facts are your data. And that logical reasoning process is what I teach you on one happy afternoon of those 5 days of my course. However, 80% of my time, it is drudgery. 80% of my time, it's not the fancy logical reasoning, but it's data wrangling, fighting with data. Some of it is actually a little bit of fun, some of it is not so much. The fun part is using your intuition to decide how many new columns do you want to create to build an interesting machine learning model. DBAs, if this is first time you are looking at machine learning, I apologize, but we love tables which have thousands of columns, in fact millions of columns sometimes, but we know you have problems with that, so we have some other tricks. And yeah, my friend Kimberly Tripp always says that SQL Server can do millions of columns, Rafal, but in reality you don't want to do that. And let's say thousands is more than enough for most of us. One other thing we love to do that you hate if you are a DBA is we don't like relationships, so we flatten everything. Yeah, if you are going to give me data that comes from your beautiful, multi-dimensional, or even just relational diagram of 20 tables interconnected with the best normalized form, I'm going to brutalize it into one flat table. And I'm sorry to say that, but there is nothing we can do about it. Pretty much every machine learning algorithm on the planet requires flat data. So guess what? Am I going to be the best person to flatten this data? No way. I need help. I need somebody who knows it. I have this help. His name is Bob. He's by far my favorite and best that I've ever worked with data engineer. I'll tell you about Bob a little bit later. But one way or another, this is the fun part. The not so fun part is like figuring out, okay, if in this data warehouse, that's a real retail scenario, customer was refunded an apple and the value of the refund is $100,000, that probably doesn't mean we have refunded a customer $100,000. What it means is that in the data warehouse, the price at which apples were sold was slightly higher than it should have been. Some report didn't add up, so they inserted a refund just to make the report look normal. How many times have you seen that? All the time. And what do you do when you build a machine learning model from that? Well, it suddenly tells you that you have some bad customers who require very large refunds. And you go predict with that. Anyway, so that part is not so much fun. What tools do you think a data scientist will need to use to cope with all of those issues? Tools that are good with machine learning, tools that are good with data, tools that are good with computers, tools that are good with the cloud. What is the most important tool if 80% of my time is fighting with data? You know the answer. That's why you are in this room. I could quote you survey after survey after survey, but I have permission to quote only from this one. So this is the one you're going to have to live with. It's about a year-old survey. SQL is the #1 tool data scientists use around the world, okay? No, not Python, not Excel, not R. They are quite close by after that. SQL is the #1 tool. And the new research, which sadly I don't yet have a permission to show, says exactly the same. SQL is still on top. The only thing that is changing is Python is becoming more popular than R, but other than that, it's pretty much the same story. Which database keeps changing a little. To everybody's surprise, Microsoft SQL Server is now leading as a favorite database for data scientists. I thought I would never live to this day, but they've done so much interesting and good work that it's now becoming an obvious choice. Of course, MySQL wins as far as the non-commercial databases are concerned, but I don't know how commercial or non-commercial anything is anymore. But anyway, I could go on with this. You know what? In fact, there's plenty of other interesting things you may want to look at if you're interested in surveys. One that came out only like a couple of months ago that would be interesting for you to look at is the Stack Overflow survey of which technologies we use as a data scientist. And for some reason, JavaScript is above that. I think that's an aberration because it's Stack Overflow, so they look mostly at developers. But it's immediately into the SQL land. And however you slice and dice that, everybody will say the same. By the way, if you look at the Stack Overflow, this is a fun one to look at. Most loved, dreaded, and wanted. I always like that. Who cares about the loved? But look at the dreaded technologies. Okay. Oh, I had to do that one too. So, what's my approach? In fact, what has my approach been for the last 13 years? The reason Microsoft get me to speak in front of lovely people like you is because I've been using Microsoft technologies to do my job for all of those 13 years. Why? Because of a little unknown technology that still people don't know about and Microsoft are not talking about and you will not learn about unless you search for it. It's hidden knowledge. SQL Server has had data mining technology, which is easy, visual, intuitive, just works. It's almost as if it was designed by Apple. It knows what you want to build before you even press the buttons. Am I allowed to say it here? I don't know. So one way or another, it's been my friend. But I'll be honest with you that it's not powerful enough. It's old. I still use it. Its visual aspects are great for prototyping, no matter what Microsoft says, but it's not powerful enough for a lot of real-world work. So about 6 years ago, I started using R, at first because I needed a little bit of kind of more powerful statistical, properly done analysis. But very quickly I realized that's not the reason I want R. R is not the most beautiful language in the world, and that's to put it mildly, okay? So why do I suffer R? 10,000 packages of software that solve any problem I haven't even thought about. Now, when I was presenting this in a 45-minute session, I didn't have time for the story, but now I do, so I'll tell you the story. When I was starting using R, I was solving yet another problem of the fraud detection type. I do an awful lot of these models. They are not the most fun part of my job, but customers want them and they pay well. They pay well because no matter how you build them, they tend to break after 6 months and they have to be fixed. No, I'm joking. Okay. The reason I needed to use R is because when you look for fraud, you are looking for something very rare, something that doesn't happen often, which is a good thing. And almost every machine learning algorithm has a problem with that, and it says, oh, this is so rare, I'm not going to look at it at all. I'll just focus on something different. So you can't build a model until you trick it. And one of the tricks is a technique called oversampling, which means that you artificially multiply fraud, so there's more of it, and it's more visible to the algorithm. But if you do it carelessly, it very often gives you bad results, or it doesn't work at all. So it takes a little bit of judgment and trial and error to get the right amount of oversampling. And you know what? I'm working for this company. I believe this was when I was developing for ATP. ATP is Denmark's largest pension provider, second largest pension or retirement company in the world by the size of their fund. And yes, I do work with the biggest one too, which is NBIM, Norges Bank Investment Management, who just crossed over $1 trillion in their assets, which is amazing because that's for a small country of Norway. And it's even more amazing as a company because they have only 200 employees. VCs looking after $1 trillion. That's just insane. Anyway, I'm getting off track. What's happening with ATP? Well, we are trying to build this model, nothing works, and I'm scratching my head, and I cannot do anything, and I'm searching, and this thing pops up, and it's called Rose, like a flower, R-O-S-E, Rose. I say, you know, I've tried everything, nothing worked, why don't I try this package? It was one of those, well, then it was 4,000 packages of software. The reason I'm telling you this story is because it worked. And without going to any detail why it worked and why others didn't work, I had a light bulb moment over my head. I had a moment over there, I looked at this package. That package was created by a professor of applied statistics, a lady from northern Italy, only 1 month before I found it. You know, that meant to me that there is some incredible minds out there solving my problems free of charge before I even know that I have these problems. I would be crazy not to want to have access to that. It would be madness. And that's why I persevere with R, and that's why some of you will need it. There are easier things to use, and I'll talk about them later. Cortana Intelligence, or to be precise, only one component of it, Azure Machine Learning, is now part of every project I have done for the last 2 years. Because it's easy, because it has some nice advanced algorithms, but the main reason I use it is because it's there. I don't need to provision anything. I don't need to build any servers. It costs next to nothing, which is why Microsoft are redeveloping it into a new version. It costs next to nothing, and it lets you prototype something very quickly, put into production for the proof of concept stage. It's perfect. It's way beyond that. And if you need something bigger, well, then you start developing something bigger. So that's my toolkit. And to give you a feel of it, I'm going to give you 2 quick demos. First, I'm going to very quickly show you literally a glance of this ancient technology that is pretty cool. It's only a glance, only like 2 minutes. Then I'll give you a quick glance of the same thing in Azure ML. And after those 2 glances, we are going to talk a little bit more about what is changing in this toolkit, starting with changes to Azure ML. So the very first glance that I wanted to give you, I always show this to people using Visual Studio, but you know what? Many of you are DBAs, so how about we use SQL Server Management Studio? In fact, you can use any of these tools to do this job because this tool works in everything. It's so old, it has permeated even Excel, even Report Server, even Visio. I've never used it in Visio in my life, but you know, it's there. All right, so I'm connected to my SQL Server Analysis Services, and over here, I have built some models. And this is the model that I want to show you. It tries to predict VIP customers. How do you define a VIP? Well, that depends on the business. In this business, a VIP customer is one that made 4 purchases or more. And if I right-click and browse that, I not only get a model, but I also see what makes my customers buy many cars. Blue is good, blue is bad, blue is false, red is good. I know, it always gets me. Microsoft, for some reason, choose usually red for the positive thing, which works fine if you come from Asia, of course. That's exactly how you'll be thinking about. For the rest of the world, it seems a bit switched. So one way or another, most of my customers are not VIPs. I have a few customers, the reddish section over there, or pink on that projector section over there, who are the VIPs. Now the question is, what makes a customer a VIP? Well, that's what a decision tree, one of the fundamental algorithms in machine learning toolkit tells you. Look at that. Where do I have most red-colored customers? Remember, red are true. True is what? True are purchased 4 cars or more. They are the VIPs. Well, you want rich customers. And if you don't have the rich customers, then you want the almost rich customers. And you don't have almost rich customers, well, then unfortunately there won't be as many 4 or more car buyers in there. And if you want to drill it further, you can find out that, for example, in this income bracket, it's the number of children at home that matters. If you have more than 1 child at home and you earn between 75 and 100K, well, can I say anything else about these customers that makes it even easier for me to decide who is and who is not a VIP? Yes, I can. I can click on the next level, and I can keep drilling it until there is no more useful information in the model. It looks like having more than one kid and having only partial high school education tends to make me much more of a VIP than having other levels of education. If you spend 5 days with me, you laugh at it. Why? Because we've kind of encoded some strange patterns in there, but that's for you to come back to me on. However, as far as this mini demo is concerned, that's it. That's all I'm going to show you. I just wanted to make my point clear that this technology is there. It's in every version of SQL Server, realistically speaking, since SQL Server 2008 R2. It was in previous ones too, but it didn't work as well. R2 was the one where Microsoft debugged it up to the point that it only has 8 bugs that will be never fixed, but there are workarounds for 7 of them, and 8, well, that's the one you will call me about when it happens. All right. Azure Machine Learning is the other technology I use extensively. This is a technology that has enabled me to build models without having to have anything ever provisioned, and I like it a lot. This is one of the models that you build also on the course. I know it says simple start, but if it's the first time you look at it, it may not look so simple, so you kind of have to trust me that this is very simple. And the idea of this model is exactly the same. We are looking at exactly the same data about our customers. We are trying to figure out whether these lovely customers that we have here, for whom we know how many purchases they have made. You see, this is this flattened data set, an example of a flat data set where each row represents a customer and each column represents something that we are trying to analyze, with one special column, number of purchases, or maybe this one, purchased 4 cars or more, which is of course derived from this column in a trivial way. We are trying to find out, is there a way to predict if this would be true or false based on everything else? And the answer is yes, there is, and all of this work that goes through here, there's a little bit of preparation of data. This is the magic component that builds the decision trees, or to be precise, this doesn't build them, this only initializes the algorithm. The algorithm is actually used here to build the best possible trees, which we then test in several different ways, and eventually you will find, let me actually show you maybe those trees, you will find, there you go. You will find, in this case, not one tree, like the one that I was showing you earlier, but 15 trees. Why there are 15 trees? Because this algorithm doesn't build just a single tree. It's called boosted decision trees. It's also known as an ensemble. Ensemble means a set of many things. Many trees are built so that if some of them make mistakes, you can always pick the average vote, like a democratic vote across all of the trees to find out what is the correct answer. It's a bit like elections, okay? I'm not going to go too far with that, but the idea is that when you have elections and you take an averaged vote, you get wisdom. All right. Moving back to the safety of the slides, let's talk about the future of Azure Machine Learning. Today, it is quite powerful. It uses a graphical user interface that you have already seen. Super easy web service deployment. I don't have time to show you that. Watch my videos or meet me or talk to me. It's trivial. In about 5 minutes, really 5 minutes, you can convert a working model into a web service running in any of those Microsoft Azure data centers, and it's so fast. Oh my, if you want to do like 5,000 predictions and you are in Dublin, where my company is based, and I'm using the data center in Texas, which is the one for various reasons I frequently use, the US South Central, I get results in less than 1/3 of a second. If I amped it up and I had 100,000 rows, I wouldn't wait for the results. I would execute it as a batch service, and it would take somewhere around 15 seconds, mainly because of orchestration. It's super fast, super easy to do. But GUI only, graphical user interface only, is not what the world wants anymore. And also, the world doesn't want just the Microsoft algorithms. The world of data science wants a little bit of Microsoft's Cognitive Toolkit, or CNTK, a little bit of Google's TensorFlow, a little bit of Apache Spark ML, and whatever comes in the future. So my good friend Jamie McLennan, who created that old SSAS data mining technology more than 2 decades ago, who left Microsoft and came back to Microsoft last year, is now rebuilding all of this stuff for the better future. And I'm so excited that he's at the top of that part of Microsoft. He's not a marketing guy, he's the real person. He's the director of engineering. He has amazing plans. And because he told me not to tell you, I won't tell you too much about them, but I'm quite excited. To cut the long story short, soon, and that's a Microsoft soon, you will see a combination of use any language you want, use any framework you want, and best of all, deploy wherever you want. So the next version of Azure ML will allow you to deploy to SQL Server, if you want to the new machine learning server, more about it in a few moments, to any Docker environment if you want, to a virtual machine provided by Microsoft or you, to Spark, or even to the edge technology of Azure IoT, which I know absolutely nothing about, so I'll just leave it at this point. Okay, let's talk about those ML servers. Let's talk about SQL Server 2017 too. So I've got about 8, 9 slides that I want to walk you through now, just to give you an idea about everything that is changing in this world. It all started with Microsoft telling me 6 years ago, Rafal, when you are in front of our customers, don't talk about R, because we will never do it at Microsoft. I'm not joking, that's what they told me. Okay, how many R's has Microsoft got today? 1, 2, 3, 4, 5, 6, 7. Yes, they went on a shopping spree. They bought Revolution Analytics, a great and well-respected company that built one of the most powerful engines out there for R. And they made it available in so many variants that nobody understands which one they should use if they are new to it. So I'll help you by telling you straight away that if you really, really, really want to do things well, you should start using straight away the one that you know best. You should straight away go to SQL Server either 2016 or 2017 and a variant of R that's in it. That is going to have everything you need. However, if you want it for free, there's R Open and R Client. If you want it to run in the cloud or on Hadoop or Linux or even for Teradata, the reason Teradata is crossed out because Microsoft will not develop that technology anymore. So the Teradata variant of our server, variant 9.1 was the last one that Microsoft made, at least according to the current plans. Or perhaps if you want to start with the next, go straight to either the SQL Server 2017 machine learning services or machine learning server. All right, before we get any further, the R language, which appears over here, is no longer the only choice that enables you to do great machine learning, advanced analytics, and artificial intelligence stuff in SQL Server. Obviously, Python is the other choice. Why obviously? Because it's a better language than R. I know that if you love R and if you are from the R community, it's hard to accept somebody else on the outside telling you that there are better languages than R. But you know, I've been in this business for more than 27 years. I've seen many programming languages. My first programming languages after a short stint with BASIC was Fortran. I learned pretty much anything that I had to. And as a former developer and still a developer and a DBA and a data scientist at heart, it's clear to me that an elegant language which looks the way it works and which is easy to understand and predictable makes people not just happier, but they write better code. And R doesn't have that. R has quirks. R, you know, if you expect that a variable defined in a function behaves differently from a variable defined outside of a function, well, then obviously you've been developing at some point in your life because every programming language copes with that. This is called scope or scoping. Well, in R, that doesn't quite work this way. There's all sorts of weird stuff that happens with where you define variables, and you have to pass so-called environments. And, you know, there's a solution to it, absolutely, but it's just, you know, Python is just nicer, easier. Also, Python is a little bit more popular. because R is really just for the data scientist, whilst Python is for everybody else. Python is for people who want to manipulate data. Python is for people who want to write glue code. This is one of the best uses of Python, for orchestrating X and Y and making this run first and something else run later. So, will you be using R as a data scientist in the future? Yes, absolutely. Why? 10,000 packages, that's all I have to say. They will appear at least for the next 10 years, first in R, but then the most popular ones, the ones everybody needs, not just the geekiest geeks, but the normal data scientists, they will arrive in Python. It's a pyramid. Actually, maybe it's an upside-down pyramid. Here are the Excel data scientists. Here are the data scientists who will use easy tools. Here are the data scientists who use Python. Here will be the data scientists that use R. And here are the uber geeks who are still writing MapReduce Hadoop code that I guess it's fun to know how to write because it makes you rich. But other than that, nobody else. Did you know how much do you earn as a MapReduce developer on the East Coast in New York? Currently, the starting salary is a cool $170,000, which is quite bad, because if you wanted to hire one of these cool kids about 4 years ago, that was $400,000 for a MapReduce Hadoop developer. So they lost a lot, I guess, is one way to look at it. So you don't have to feel bad about not picking on that career. All right, if you are going to use Python, you are going to use some libraries with it, because the bare bones, naked Python does not do data science, if at all, then certainly not well. You'll use a library for numerical processing called NumPy. You will use SciPy for scientific processing, and to be honest with you, you don't even need to know that you are using it, because you will probably be using scikit-learn, which does all the data mining or machine learning, plus Microsoft ML and RevoScale-Pi. The reason there is a star here is because I'll come back to them in a few moments, because that's what you get from Microsoft that you kind of need to install something else for. One of the other packages you will use is Pandas. Pandas, nothing to do with fluffy animals, stands for panel data. Panel data is what econometric students call tables. Tables, as you know them in SQL Server, are called panel data in econometrics, and that's why we call this package Pandas when you want to put data in a table in Python. And now you are thinking, doesn't Python have normal tables? It does, but they are not good enough for machine learning and data science. What you need is a table on steroids. You need a table that knows how to do singular value decomposition and matrix computations inside it, and that's not something that normal data structures do well. The same story applies to R, and in R you also use data frames. Data frame is the R name for panel data, or in other words, it's the R world name for a table on steroids. And don't worry, you don't need to know anything about singular value decomposition or matrix computations for the first year of you doing this job. Okay, R and Python doesn't deal with complex data analysis. Yes, big data, that's what I'm talking about, but I don't like using the term big, because small data can be complex. In fact, it's nothing to do with the data, it's all to do with the question. Bare bones Python is better than R, but there is something much better. And this is why you are here in the Microsoft room at a Microsoft conference. After buying Revolution Analytics and a couple of years of very hard work, Microsoft has improved the performance of both R and Python for large and small, basically complex data machine learning analysis using the technology that's in Microsoft SQL Server 2017, machine learning. This exists in two forms that I will explain in a moment. Basically, what they give you is automatic parallelism, automatic scalability in terms of memory, but also things that don't fit into memory, no need to move the data, and finally, all the usual Microsoft enterprise niceties like security, Azure, and on-prem Active Directory, and so on and so on. Okay. When I was preparing this slide deck, if you downloaded my slide deck even 3 days ago, I was talking about Microsoft R Server 9.1. Oh, hold on, Rafal, you always have to rewrite your slides the night before. Yeah, last night it all got renumbered, and that's why it's crossed out. and it hasn't gotten renumbered just into a different name. I'll come to that in a few moments. But let me just very quickly cover. Microsoft R Server 9.1, until about 3 days ago, was licensed with SQL Server Enterprise Edition, or in Azure under the name of Microsoft R Server for HD Insight. It's a funny announcement that came out around its time, which is we will no longer support HD Insight for Windows. From now on, we recommend to our customers Linux, because everything is better in Linux. I thought I would never live to see this day. It's an official announcement. Look it up in Azure, look up why HD Insight for Windows is being discontinued. Crazy, crazy stuff, isn't it? Obviously predictable, but still crazy. Anyway, it's a separate download, which is very different from the way you may or may not have installed R Server with SQL Server 2016, because in SQL Server 2016, it installed for you R Server version 8, but you don't want to use it, okay? That one was Microsoft product version 1, and everybody knows, even though it says 8, it's just to make you feel better, okay? It's version 1. Version 1, never use. Version 2, they always mess up. Version 3 is the first version you have to start trusting, okay? So not version 8. I could explain later why, but I don't have time. To cut the long story short, forget about it. Who cares about it? We now have Microsoft Machine Learning Server 9.2.1, which is funny because yesterday morning we had 9.2 and yesterday evening we had 9.2.1. So I'm writing my slides and I'm thinking like, what has happened over there? So it's kind of fun how I know whether the developer is presenting at the conference and he said, oops, that was a good question, let's just rewrite the software. One way or another, it became available last night. Last night, Microsoft pumped it into Visual Studio Essentials. It's not yet available for download from MSDN or the volume licensing stuff, but it will be in the next few days. Very interesting stuff. It's licensed with SQL Server, including Express Edition. No longer just Enterprise. But don't you worry, Microsoft has a way of asking you to pay for the Enterprise Edition, because multi-threading and parallelism only come in the Enterprise Edition. So basically, if you want the performance, you're going to pay for it. But if you want to get started with it, it's free. Two things, ML Server, which is standalone, and ML Services, bound to a SQL Server instance that live on the same computer as a SQL Server installation, but thankfully now installed to a separate set of directories. So all of your DBAs, I know how protective you can be of C:\/ wherever I put my SQL Server. It's no longer going to need anything changed over there, so you can lock it down, unlike the previous versions, which kind of blew it up, and all of your security things kind of were under a question mark. All right, what's new? Well, first of all, what was new, you see, I've been editing my slides last night. What was new until 2 days ago was the Microsoft ML package, the ability to deploy web services using the Microsoft R Server deploy package, and I apologize, but I always will call it Mrs. Deploy package, and a very new functionality for reading from SSAS multidimensional cubes using MDX called OLAP-R, which makes my colleague and good friend Christopher Webb very happy, I hope. But since this is old news, let's talk about the new news. The new news, as of yesterday evening, is that Microsoft Machine Learning Server 9.2.1 not only has exactly the same Microsoft ML package it had in the prior version, that's 9.1, not 8, and not 9.0.1, which was the mistake they made that that was version 2. So it's really version 4 now, right? Except this package is really version 3 because it's the same, okay? You have no idea how much work I had to do just to understand it myself. What is new is in 9.2.1, they added Python support. They did it in a very clever way. They basically copied and pasted all the functionality from the R package version of Microsoft Machine Learning Technologies into, we are now going to offer it to people who prefer Python. And what do you get in there? You get data transformations that data scientists use, like creating very quickly hashes of text and creating columns from those hashes. So you can create these millions of columns if you want. Parallelization of anything you want. New pre-trained algorithms. I'll show you one in a demo coming very shortly. And the coolest thing they've done is those incredibly powerful, fast fairly large data algorithms for some of the things that data scientists want to do right now. Look at the numbers. Being able to build models from billion columns by billion rows in SQL Server. You can build neural networks on an infinite number of rows, obviously subject to how long you want to wait, but it's very fast and it can cope with 10 million columns. Why would you want 10 million columns? Everybody in this room is thinking about that right now. Many reasons. First of all, if you remove every possible relationship from your super uber normalized, that's where it goes. Yeah, incredible amount of redundancy because we are now replicating everything by denormalizing the data. But you wouldn't get to 10 million that way. That way you would get maybe to hundreds of thousands. The millions of columns usually come from what's loosely known as unstructured data. An image, a megapixel image, is 1 million columns. Yep, that's how it's done. You basically convert every pixel into a column. I'm not joking, that's how it's done. It's trivial. Actually, image analysis is so easy. You just need to know the tricks how to make it run, and this makes it run some way. This is new, GPU acceleration. You can get something like 8 times or more improvement in performance of a neural network if you have an NVIDIA set of NVIDIA cards. Who would have thought that your next SQL server, when you are speccing it, you'll be thinking, how many GPUs I need on this server? Isn't that crazy? I'm still waiting for Microsoft to confirm if they're going to charge for the GPUs as cores or not, so I don't know the answer to that. I asked the question 3 times yesterday, and hopefully they'll answer, but hopefully not. Hopefully they haven't figured that one out yet. So it's just... All right, 9.2.1, other than doing all of this cool machine learning stuff, both in R and Python, also adds interesting support for creating your own web services on a server. So basically, there are 2 deployment modes for how you build your analytics, either in SQL Server, which I will talk about in a few moments, or forget about SQL Server and its queries as a way of predicting. Let's just offer a web service. Mrs. Deploy is how you do it for models created in R, and Azure ML model management SDK is how you do it in Python. With or without Azure. The reason it says Azure ML is because this is also a hook to how you can connect to the future version of Azure machine learning in the cloud. There is yet another technique for real-time queries which reduces latency dramatically, but it limits you to which functions you can use to make queries with, and the OLAP R package, which I already mentioned a moment ago. Okay, time for a quickie demo of one of my favorite things Microsoft have added, and it is the pre-built models. How many of you have had to answer somebody a question, could we do sentiment analysis on insert whatever you want here in our company? No, not as many. For me, it's like every company wants to do the sentiment analysis. And it usually starts with, let's hire a data scientist, or one of those, let's build a model that's going to take like 5 months to build before you have anything. Well, you don't have to. It's all done for you. And just to give you an idea, I'm not going to run this setup. You know what? Last night I thought, should I upgrade to 9.2.1 or not? And I spent like half an hour thinking, all of my demos work. Wouldn't it be cool? I chickened out. So I thought I'll show you the setup screen. Because you know what happens if you change your demos like a few hours before you go to bed? And that was like 1 in the morning, 9 a.m. session. No. But I'll show you the setup. This is the box that you want to tick. The box which says pre-trained models in the setup. And by the way, this is where you bind it to a SQL Server instance if you want this machine learning server to be usable from within that SQL Server. This box gives you something pretty cool. It gives you pre-trained sentiment analysis as well as image recognition technologies without you having to build any models at all. 4 lines of code is what it takes to do sentiment analysis. Currently only, I'm afraid, in English, but about 8 other languages, including French and Japanese, are coming along. Japanese is actually quite easy to do. If you think about Japanese and Chinese, those guys have it easy because the character has a meaning. Have you thought about that? No. Incidentally, we have a secret tool. If you are analyzing sentiment of anything, never strip punctuation. Never strip emojis. Emojis are good. Get that? All right. Okay. Here's an example. This is my data, 4 sentences. These 4 sentences are stuck into a data frame. What's a data frame? It's a table. This table is called customer reviews. And I'm going to pass those customer reviews to get the sentiment of those customer reviews using the rxfeatureize function. Rxfeatureize is the function provided by Microsoft ML package for R, and you have exactly the same version of it for Python. It's easy to recognize what Microsoft have created because they all have Rx in front of them. Why R? Because that came from Revolution Analytics. After I calculate that sentiment score, I simply compare the returned values. Here's your first lesson in the R language. Dollar is a dot. Basically, when you say table, dot, column, in R we say data frame, dollar, and we don't call them columns. Just to make life more difficult, we call them variables, but it's basically a column, okay? If the score is greater than 0.6, that means the text was kind of awesome, and if it's less than that, well, it wasn't very exciting. All right, let me just select it all. Let me run it. It will take a moment to get all the technologies going, but in a moment you should be able to see those scores. And this model was built from something like 1 billion sentences using Bing. There you go. It looks like pizza was good is the most awesome sentence here, according to this sentiment analysis machine. But this is a conference, doesn't seem to look good. So we're going to change that. We're going to say this is a nice conference, and we're just going to rerun this guy to see what happens. Hopefully the sentiment will be a little bit better. This is more designed for batch processing rather than for calling. Look at that. That already shot up. This is a nice conference. It's suddenly an awesome sentence. Remember the score, 93% of awesomeness. We're going to stick an exclamation mark at the end. 93%, 93%. He's added an exclamation mark. Is it going to be clever enough to do something with it? Well, we'll see. And look at that, went to 95%. Well, how about we stick like loads of exclamation marks? Do you think that's going to be better or worse? Remember, 95%, 95% awesomeness, 95% awesomeness. And now, oh, it went down, because everybody knows that 1 exclamation mark means you really thought about it. Many exclamation marks is like, yeah, you know, whatever, you just hit a key. Yeah, that was awesome. This is pretty amazing. No, it doesn't cope with everything. It doesn't cope with all forms of sarcasm well. It does some sarcasm. From experience, it has some issues with British sarcasm, but, you know. We hope there will be a British English version at some point. And then there will be the Monty Python edition. All right. Oh, by the way, those 4 lines is all you need. And you'll find a version of these 4 lines on MSDN. It's in the official Microsoft documentation. SQL Server 2017. This is why you've been at this session, I hope. Well, the cool thing is that both of those machine learning servers come with SQL Server 2017. You can have both the standalone one, which binds with SQL Server 2017, but can be used without SQL Server 2017 completely. And it comes also with the in-database machine learning services, which enable you to run queries against the model from T-SQL. And there are 2 ways you can do it. One is the one that Microsoft already had for a year, which is SP execute external script that I'm going to flash on the screen in front of your eyes in a moment. And there is something new that I'll show you on the next slide. The new thing, comparing to the previous version, which was R server, is, of course, that we have Python. But the other thing that is new is that integration with the next version of Azure Machine Learning is coming along whenever Microsoft launched that. And the preview in the form of that Azure ML package is already available. But the biggest reason why it's important to me, and I hope to you, is because T-SQL is now even closer to machine learning. And fundamentally, that's what you want in order not to lose control over your data. If you have some sensitive data or you have a lot of data, you are responsible for this data and you don't want people uploading it to some external technology where possibly it's going to get damaged or abused or maybe even copied. By keeping data where you believe it should be and bringing machine learning towards it, you have not only that control, not only the safety, but also some huge speed improvements. That performance and scalability is the reason you're gonna like this technology. One little point to make when talking about where should data be, there are people who argue that you shouldn't be doing machine learning in the database. I'm not one of them, because that's exactly what I've built my business on 13 years ago. Remember, my SQL Server analysis services, data mining, that technology I showed you at the beginning that nobody knows about, the reason it made me successful and I built my home and had all the fun holidays and vacations and employees is because I had machine learning within the data engine. So I am more than converted, but some people disagree with me. All right, the other cool thing that's coming to SQL Server 2017, which in a keynote yesterday, Microsoft said for the first time, we're going to have a predict statement in T-SQL. Well, strictly speaking, yes, for the first time in T-SQL, but not for the first time in SQL Server, because we had a predict statement in SQL Server Analysis Services for the last 17 years, but them execs, they don't know about that. It's old Microsoft technology, so that was in a keynote. Predict statement in T-SQL is kind of something some of you will want. Basically, if you work with data science and you decide, that's for me, you don't care about it. But if you decide, oh, I'd rather not do it, I'd rather have somebody else do it and just give me the model and I'm gonna use it, this allows you to use a model without having to install R, without having to install Python, in fact, without installing the machine learning server or services at all. How did they do that? Provided that your model was built using those technologies, you serialize the model into a var binary, which ends up somewhere there, and that's what you pass to the predict statement. And that predict statement, basically model, here you can stick a literal, you can deserialize it, you can reference it, then you pass some data to it, for example, from some table. This thing will predict whatever the model is designed to predict. So if this was a model that predicts if customers are VIPs or not, you remember I showed you that model, the score will be some kind of a probability that this customer is a VIP. The with statement allows you to define the schema that will come out from this clause. And I'm showing to you here in a select, but of course, you would use it in an insert, you would use it in an update, you could use it wherever you want. That is going to make your life much easier. Number two thing, managing dependencies. This is probably the worst part of IT today. No matter where and who, if you are managing dependencies of multiple versions of Python, R, with these packages, and there are 10,000 of them, it becomes a headache. So what Microsoft have done in SQL 2017 is they allow you no longer to have just the most current version, which obviously wouldn't work because things would break, but you can have any version of these tools, any version of the packages. They are tracked in a database which is associated with models, with applications, and that's something that you can ask the external party to give you. You just need to insert it somewhere and suddenly everything coexists. It's not perfect, but it is a huge step towards solving the dependency management issues. Bear in mind that this is SQL Server 2017. That is not available today yet. That technology you'll have to wait a little bit for. All right. What I would like to do now is to give you a kind of a quick demo why you want to have these technologies in SQL Server. And with apologies that I'm gonna show you this in 9.1, but as I already told you last night, I chickened out. I thought I'd rather show you a demo that works than have to wave my hands and have nothing to show. Having said that, even if I updated to the new version, 9.2.1, the demo would be line for line identical because nothing changes in the code. The only thing that I hope they have solved is there is a delay when you get results of about 5 seconds on a Windows 10 machine. You don't get that delay on a server. That's one of the outstanding issues out there. I hope that has been solved. You'll see this delay here, but it's not going to affect our demo at all. All right, I'm going to spend about 9 minutes or so in this demo, just giving you an idea. I'm not going to dive into detail of it. If you are interested in the detail of it, you are more than welcome to watch my videos and join me and so on. Actually, I'm going to give you this demo in 2 sections. First, I'm going to show you something that doesn't work, and then I'm going to show you something that works so you understand the difference. I know many of you have not seen R before, but you will understand this code. It's very simple syntax. What I'm showing you here is a traditional tool people use when they work with R called RStudio, but I could use Visual Studio and R tools. It's just that I want to have a version in R server here and a version without R server here, so that's why I'm using two environments. It's just for demo purposes. All right, what these lines will do when I run them is they open through ODBC connection to my on-premises SQL Server to read 10 million rows of data. I have a table called mort default somewhere on my server over here, and has basically 10 million rows of data representing mortgages given in the United States. It's a well-known data set available from Microsoft for you to play with. You probably, as there are a lot of Americans in the audience, recognize this credit score very well. To Europeans, if you've never seen the Fair Isaac Corporation or FICO credit scoring system, it's a number that averages with a normal distribution around the center point of 700. So 700 is considered to be an average American credit score. The question is, can I build a model that predicts just from this data your credit score, how old was the house you bought, how many years you have been employed in your current job, your credit card debt, and when did you buy a house? Will you default on your mortgage? And 0 means everything's good. Anything other than 0 means a default, unfortunately, took place. So, why was I talking about it? Because it took 19 seconds to load this data into R. Well, that's not bad, actually. But that's as far as it goes in regular R. If I want to show you the 10 million rows of data, this takes forever to show. And then if I touch the scroll bar, I will kill my computer because it will actually hang up. So I'm moving the mouse as far away as I can in order not to touch the scroll bar. Okay, that's as much of looking at data as we are prepared to do. Now comes the fun part. I'm going to run this. Actually, I don't need this whole system time because it will never finish. What have I done over here? Good. Okay, let's just run this statement. This statement tries to predict the risk of default as a function of, which means from house age, year of purchase, credit score, plus doesn't mean addition, it means and. It's a very, very dirty syntax if you think about it. And GLM stands for Generalized Linear Models. Basically, it will build what's known as a logistic regression, one of the fundamental techniques in machine learning. But you know what? I don't need to explain to you because it will never finish running. And because it will never finish running, we're going to have a little bit of fun looking at what happens with the CPU, actually what happens with the memory of my lovely little server over here. Okay, I'm going to have to not speak too much as it runs because I have to kill it before it kills me. It started. And in a moment, I'm going to have to stop this process from running. Where's my stop button? Okay, the stop button is there. Look at this. It's eating all the memory. I'm going to let it go up to about 90%, and then I am not going to hold my nerve much longer because it will lock up the computer. Okay, I can push it a little bit. Okay, that's pretty much when my nerves go. Okay, so I'm stopping it. Oh dear. Right-click and task. Good. I've managed. If I didn't kill it, trust me, it would have never finished, but it would have also completely and utterly shuttered my computer, requiring a reboot, and there would be no more demos in this session. Why? Because that's what R and Python would do. They try to load all the data into memory, all 10 million rows, which is not a problem because you can provision an Azure machine with 2 terabytes of memory, right? No, it is a problem because it does it very inefficiently. Worse than that, it tries to read from the first and the last and the middle and the last and blah, 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 like that, approximately 10 million times. And because it doesn't have space for all of that in memory, you know what it will do? It will use a 30-year-old technique known as paging or swapping. Rather than deal with the problem of data being in the wrong place, it will actually page out the whole program to the disk and back from the disk. And basically, that's how it kills the computer. Great memory test on your server. If you have any problems with memory, you're going to get a blue screen. Anyway, how else would you do it? This is how you would do it. This is in the R server, or machine learning server, as it is now called, using this statement which executes instantly, I am not reading the data into MorphDS. I am merely establishing a connection to my SQL server, and you can see there is a query that extracts this data. Why did I not do select star? Because Bob would kill me because that's not the right thing to do. He explained to me, yeah, okay, no, there's another reason. If you name the columns, it parallelizes the data extraction. It can do extract of individual columns on different processing nodes. How cool is that? Anyway, so one way or another, I'm connecting using integrated authentication. That's what trusted_connection equals true does. From my local server, databases, mortgages, and a parameter you kind of need to tune to your server, in my case on a laptop, 1 million rows at a time. If I wanted to browse this data very quickly, I could do it over here to get a sampling of 5 rows of data. This is just a check to make sure everything works. Look, there's this 5-second delay every time I press. This should be instant. But that 5-second delay is a penalty on Windows 10. That's the one thing I was rather hoping it was already resolved. It was on a Microsoft to-do list. It doesn't affect the server. When the SQL Server is installed on a Windows server, as opposed to on a Windows 10, as it is in this case, you wouldn't have that delay. Anyway, the connection works. So what can I do with it? That depends how much time I've got. Shall I show them the full one or the short one? I'll show you the full one. All right, we're going to do it the slower way first. I'm going to run it because it's going to take some time. It's going to take 156 seconds on average to run, so I have about 2.5 minutes to tell you a story now. As it is running, this code is doing exactly the same thing that we've done in normal R. There are a few minor wording changes. We are using rxlogit rather than GLM, but who cares about that? To predict the default from the housage and the year of purchase and the credit score and year's employment and the credit card debt. Data is now in MorphDS, which obviously is that connection which we have established over there. There are a couple of tuning parameters, and other than that, we are processing it using exactly the same algorithm. Okay, it has to read the data 100 million times, so we are about 25% of the way. So what I want to show you while this is happening is what is happening to the memory. Well, it's not using memory. Can you see it's not using memory? I mean, what is it using? Can you see what it's using? The R engine is using 184 megabytes. Do you remember megabytes? Okay. Obviously, that's good, but something's not right. Why is it not using all of my awesome CPU power on this fabulous laptop I have? Because this is not the right way to do things. Even though you can do it, and it will finish, which is better than it never finishes. You know, the one in normal R never finishes. There are better ways to do it. The problem is that right now I am doing R server standalone, machine learning server standalone operation in the machine learning server, but the data is in SQL Server. The data is flying to the machine learning server all the time. So it's much more efficient in moving the data, and it's much more efficient in the algorithm. Why? Because it doesn't use memory. It uses sensible form of parallelism that has a rather cool name of PEMA, or Parallelizable External Memory Algorithm Architecture. Go read about it. This is why it will finish. But all of this sending back and from, wasn't it supposed to be in memory, in server, in database? Ooh, that was faster. It's normally 156 seconds. That's why it took me 20 more seconds, I think, to explain it. I'm sorry about that. All right. 134 seconds, better than infinity, right? So that's good news. Could it be faster? Yes, it could. I could show you several improvements, how we could do it on premises. I'm going to skip through that. I'll go straight to the good bits. The good bits are here. I am going to create a SQL Server compute context. By running that, and then by switching the... Oh, sorry, I need to recreate a shared directory over here. My apologies. And once again, I'm going to create the SQL Server compute context. And now by switching the compute context to the server, every operation that's prefixed with letters Rx will now execute in database in SQL Server. And I'm going to run exactly the same statement that we ran before for your viewing pleasure. You will not see the results, however, until it finishes, because everything happens in parallel on the back end. So we're gonna look at what happens here. Look at memory, look at CPU, look at this, 10 processes started. 10 processes, 10 communication components. Yeah, my CPU is getting burned. I love that. Why? Because I'm getting my money's worth. I paid for a nice laptop with a lot of CPU power. I want that CPU to be beaten as hard as possible. 27 seconds. You have no idea how exciting this is to a data scientist. Logistic regression on 10 million rows of data in 27 seconds? Take my money. That's how that's how Revolution Analytics ran their business. Basically, anybody in finance was used to, like, okay, that's going to take like an hour at least, or, a round of golf. I don't know what DBAs do in finance companies, but I suppose you go for golf whilst processes and stored procedures run. Well, this is a pretty amazing result. Okay, ladies and gentlemen, as cool as all of this is, I have given you only a glimpse of what this technology can do. I wish I could take you in depth into all the other fabulous stuff. How would you call all of this? How would you operationalize it? How incredibly easy it is to write SP external script invocations to use the model. Okay, that's a trivial example maybe. This is a less trivial example. This is how you do it in real life. But all of this stuff is out there ready for you. But that's not really the only reason why we need you in the business of data science. Let me spend the last 5 minutes of my presentation, or to be precise, 6 minutes and 32 seconds, telling you why you are the chosen ones, okay? You see, when we solve the machine learning, data science problem, we start with a business problem, we find some data from which we build models that solve the problem, that change the data, that change the model, and the cycle continues. However, a real-world team that does that requires people who match onto those activities very well. I need a business person, I call them the domain expert, to tell me if I'm doing my work well from a business perspective. I need me, the data scientist. But I badly need Bob, the data expert. I need you to do all the hard work, not just in removing apples at a $100,000 or $100,000 refund. I need you to think like me, to prepare the data in a way that will be suitable for analysis, to operationalize it and to tell me, Rafal, this is not going to work because on our server that would run for 3 hours and I need to create a control table with this and that and whatever else. This is the first reason we need you. I'll give you an example. When I'm doing fraud analytics, after the business person tells me what is fraud, the next thing I need to do is get me someone who knows data in this company. Tell me about every table you have seen in your work, in the warehouse, in OLTP systems, wherever, that shows anything that is correlated somehow to fraud. Information about claims, products. You know, the business person doesn't know it, the developer doesn't know it, but usually that man or the lady that has been there for 7 years and has built, the second or third generation of your data warehouse has that perfect knowledge. Oh yeah, Rafal, we have this table nobody uses. It probably has the columns that you need. Once I get that, maybe I can build those predicting models that predict if fraud occurs or not, but as soon as I deploy them, this data will change and I need you again. Let's talk a little bit about artificial intelligence and how it relates to you as a DBA. Artificial intelligence is nothing different than what you have already seen, with one magical additional connection. As we build these models, we are increasingly using them for software to make autonomous decisions. As a result of that, there is less fraud, so your business changes for the good. As a result of another model, you targeting VIP customers, you get more VIP customers, so the business changes. But your competitors don't wait. They will take up the customers you don't want. They will react with different pricing, and fraudsters will invent new fraud. Your models must evolve. If you connect with this arrow the fact that business change necessitates the evolution, continuing evolution of machine learning models, two things should become immediately obvious to you. The first one is that you will be in this business forever because we are constantly revising the data. This is not a one-off operation. You need to build an operation within your department, wherever you are in your company, to orchestrate and automate this continuing data preparation. And the second one, which you didn't realize unless you read this book by Rafal and Norvig, one of the well-respected professors of artificial intelligence, is that you've just built an artificial intelligence system. A system that changes its behavior as a result of its actions and the reaction of the environment is considered to be AI. And since the models evolve, the decisions your system makes tomorrow will be different from the decisions it made today. If your system today said, this is not a VIP customer, but as a result of new data, reactions from the world, tomorrow it says this is a VIP, it changed its action based on the environment. In other words, it perceives its environment and it maximizes its and your business's chance of success. How cool is that? You are building AI without explicitly building AI. And if you are wondering, is this really AI? Oh yeah, this is like 95% pulled out of thin air, of course, of all of AI I have seen. There is a tiny, tiny group of AI which is different, which will grow in the future. I talked about it in my presentation yesterday, but the vast majority of AI that everybody does today is exactly that. And the heart of it is that as the business changes, those machine learning models, those logistic regressions, those decision trees need to be updated. Yet another serious workload for you to consider as a DBA. And finally, we need you, DBAs, because we have different comfort zones how we fight with data. The best way to get good data is to get good data at source. That's impossible. The next best is to fix it in a tool designed for it, which is SQL. And in decreasing order of appropriateness, with R being the worst and Python almost the worst, you will modify the data this way. Guess what? Data scientists don't understand SQL. Data scientists need you to help them. We will use the tools we are comfortable with. We will tell the world that Python is the best for data preparation, but it is not. If I have learned something in the 13 years of working with companies, is that the biggest rocket under their seat that I can put, oh, how appropriate considering where we are, good metaphor, rocket, is by having the DBA transition into the data science team. Company after company after company after company. I just came from Canada, one of my favorite clients. This was one of their biggest successes, also one of the largest cinema networks in the world. By making the DBA part of the team, they are suddenly able to do things that were not possible before. All right, ladies and gentlemen, practical data science is not engineering. It's a scientific method of reasoning for solving business problems. DBA quality of data expertise absolutely makes or breaks it. We will never be as good at that as you are. Machine learning enables advanced analytics and even artificial intelligence, but to do that, we badly need you. If you would like to learn more about it, I would be honored to see you on one of my courses, Dublin, London, also Prague, Stockholm, or Chicago, coming up very shortly. Or stay in touch, register on projectbotticelli.com/connect, follow me on Twitter. If you took a picture, tweet, I'll retweet later. All I want to ask you at this point is if you would be so kind, I'm a data scientist, please complete the survey. The more surveys completed, the better for the data scientist, okay? Please complete the survey. I would appreciate that greatly. That's how we get invited back. Other than that, enjoy all of this new technology and good luck in your job and see you next time. Thank you very much.